Right, let's look at these Myimaths questions of trigonometry, Sokatua, harder ones. Alright, the first thing to do here is, well, look at what we can find. We see here in the first question that this is a isosceles triangle. Those two legs are the same. It also tells us there it's an isosceles triangle, so always look at all the information they give you because you know you're going to use it. So if this is 9 centimeter, that is 9 centimeter. Okay, from this, this is interesting. Okay, we can use this triangle here, which is of course a right angle triangle. And in this right angle triangle, let's see what we have now. Okay, we have 9, which obviously is the hypotenuse. We have this angle here, and we want to find out, if we can find out this length here, which is exactly half x, we can double it and we got x, and that will be the adjacent side because it's right next to the angle that we have. Okay, so looking at Sokatua, having the A and wanting having the H and wanting the A means we're gonna use K. So let's write that down. We're gonna write cos. First, then comes the angle. In the ratio, A is first, so that goes at the top. A is what we want to know. So let's call that half x, or let's leave it as A, as the adjacent for now. And second is the h. The h we have, that is 9. So we need to multiply the 9 on the other side. So it'll be 9 times cos 73. And that will give us the adjacent side. So we grab our calculator. We put in 9 times cos. No, there's no 9. Where's the 9? 9 times cos 73. Answer 2.631. So A equals 2.631. Alright, it says give the answer to 1 decimal place or better. Well, that of course A is only half. So first what we need to do is we double it. So we times it by 2. And then with 1 decimal place there, 5.26 will round to 5.3. Nice. Okay. Let's change the colors here. Okay. Right, looking at the next one. Okay, what angles can we find? I just want to make this a bit narrower. Let's use a different color. Right, so if that's 52, then this will be 52. Okay. And being a rectangle, we know that the diagonals are the same length, so this will be another isosceles triangle. So if we take that 52 and we subtract it from 180, we get the size, no, not divide, subtract, subtract. Okay, we get the size of the other two angles, and we divide that by 2, we get the size. So this is 64, and this is 64. Okay. So, all we really need is one angle and a right angle triangle. So, in this case, we don't really need this one or this one. Okay. What we need here is this triangle, which is a right angle triangle. Let's shade it in. So here I've got a right angle triangle. Yeah. And in this right angle triangle, we have, okay, an angle, and right next to the angle, that is the adjacent side, and right opposite the angle is the opposite side. The hypotenuse here, the third one there, we don't have it, we don't want to know it. So we're working with the O and the A. Okay, so meaning this time we're using 2R. Alright, so let's write that down. I just don't have a lot of space here. I'm going to use the space and I'm going to rub it out. So we got tan, then the angle, 64. And then in the ratio, first is O, in this case, which is the x, so x goes at the top. And next is the a, which is adjacent, which we have there is 17. So again, we just need to move it to the other side, so it's 17 times tan 64, that will give us x. So let's get that calculator out. This annoys me. Okay, so we're gonna do 17 times tan 64, close bracket, 34.855, rounded to one decimal place, 34.9. Okay, it's all going really well. Okay, I need to make some space now for the last question. I'll rub this out, all that clutter. Okay, yeah, so we got nice lot of space. Let's pick a nice color. And let's go. Last question. Let's see. First, read the information at the top. Okay. So what? We have a right angle triangle. Brilliant. SOHCAHTOA is going to work. And AD is the bisector of angle BAC. AD is the bisector of angle BAC. Nice. Okay, so that simply means that it cuts this angle in half, so that one is 20 and this one is 20. Alright. So, what does that mean? Okay. We need to be careful here. That doesn't necessarily mean it cut this line in half. I think that's a mistake that was made earlier. So this line is not cut in half. The angle is cut in half. What can we work out here? Okay, we can now work out in the big triangle. Let's shade it in. Okay, in the big triangle here. Alright, we have an angle that is these two together, which is 40. We got the adjacent, and then the whole side here, BC, is at the opposite. Okay, so again, the O and the A, gonna use tan, so let's write that down. Tan, 40 degrees, is the opposite at the top. The opposite now is this length, BC, the whole line on the side, over the adjacent, which is 27. So again, we need to multiply that on the other side. 27 times tan, 40, that will give us BC. Let's do that. 27 times tan 40, no, that's not 40. There, 22.655. That will be that whole length, BC. Let's write it in. So there's the whole thing here. The whole length, the opposite side, will be 22.655. Put a bunch of digits because we're not rounding yet. So this is 22.655. Alright, all of it, not just X. Now let's swap colors. Let's go for green. Right. I think what we need to do now is we use the small triangle. This one here. Yeah, you see this one here. And then we can work out BD. Okay, so in the small triangle, this is still the adjacent. And this is still the opposite. So again, we need to do tan. Exactly the same. Tan. But now we use the 20 because it's a small triangle. Opposite now would be BD over the adjacent, which is still 27. Multiply it to 27 on the other side. Let's do that. So as we got doing the same, we just changed that for a 20. 9.827. So this is 9.827, etc. Okay, so if we subtract the one from the other, of course, if we subtract from 22.655, we subtract the 9.827, we will get the length of DCX. Let's do that. Let's put in 22.655 minus 9.827, 12.828, and now is a fine time to round it to one decimal place, 12.8. So you got the answers. Let's just for fun see if you're right. So first one I said was 5.3. How do I need it? No. 5.3. Yeah, that went right. Okay, second one, we said that was 34.9. So this one, 34.9. No, there's no decimal point. There, 30. No. I don't know how to do this. Yeah, that's it, 34.9. And the last one, 12.8. 12.8. Come on. Yes, 9 out of 9. We know it's right. We've done it. Everybody can do it. Well done.